pressure on you. I'm just gonna, this is the beginning, honestly, it's pretty straightforward. We have two parts, we have a table and we have a tree. They're very separate, you can implement them very separately, they're different data files, so if you're really having trouble with the table and you just want to implement the tree, of course it's a smaller part of the homework, but you can do this. The only thing that's linked is the very last part of the assignment is so that when you hover over one, something shows up on the other. But you can populate the two completely independently. So not, if you can't do the first part, you can still go on and do the second part, okay? So, if we go to the learning goals, so the first learning goal, which was what we originally had you guys do, is now only part of the hacker version, is data transformation. So getting a CSV file, which is just a list of rows, and aggregating it in a way that makes sense. So the main purpose of this homework is to show the results of the FIFA World Cup, the 2014, as a function of country. So the data aggregation step would be the data manipulation. We have one row, if you open the Excel file that has our matches, it's one row per match. So we have Brazil, Argentina, Germany, Brazil, and so forth. And but the way we want to show it, not there. He's what? Oh, he is outside. Yeah, could you? I mean, he's outside, like, just hanging out. So in this case, so this really goes along the lines of data exploration versus, what was the other one called? Oh my goodness. You either build a visualization to explore and find new things, or in a journalistic sense where you just want to show something, right? So you know how you're going to visualize the data before you start. So if we know we're going to visualize it by country, and we want to show the country that had the most goals, we're going to have to take this flat CSV file and aggregate it by country. So you guys can skip that step right off the bat and load in the FIFA matches.json. The FIFA matches.json has the data in the format that you want. So if you scroll down to where it says, so you're going to scroll, I'm going to go past all the explanation of the data aggregation, since that's the hacker version, and we'll give time we can go back to it. But if you get to, right before we start with part 2, there's a snippet of the JSON file right there. Does everyone have that on their screen? And if you don't, you might want to scoot over and see next to someone who does, because I'm going to explain the data format here, and this is very important. Okay? So, every element in this data has a key and a value. Okay? The key is the country name, so we aggregated it by country. So Brazil is the key, and the value is the list of all the games that country has played. Okay? Now, as you can see, there's several things in this value field. We have the goals made, goals conceded, delta goals, wins, losses, results, total games, type in games. And I'm going to explain what each one of those is. If you look at the Excel file, you'll see that for every game, they either won or they lost, and they made X goals, and they conceded X goals, meaning that the other team did against them. Okay? So every game is represented twice in the table. The first country is, all the parameters are a function of the first country. So Brazil, Argentina, Brazil won or Brazil lost, Brazil made this many goals, Brazil conceded. There's another row for Argentina, that same game, where the numbers are inverse. Okay? So, do you know why, does this hook up to this is hooked up, and no matter what I press, it doesn't show up there. You're going to make me look out at pressing one thing, and it will show up there. That's what I pressed. I mean, that's all that shows up, and then nothing else. Did you do something? Yeah. It came up when you, one more.
So push that.
Of course. Why didn't I think of that? Thank you. Thank you, Asma. So, this is much better. So, remember how I said the Excel file had one row for each one of these attributes? The way we've aggregated this here, and if you're going to do the hacker version, you're going to do the data manipulation yourself, is that for every country, we sum the values for all of these. So Brazil, in all of its games, made a total of 11 goals, conceded a total of 14, so the delta there was -3, won 4 games, lost 2, we're going to go into the result in a little bit, played a total of 7 games. Now, if you took a look at our working demo, you'll see that our table has 2 types of rows. One is the summary row. So it represents one country, has one row. And that is where we're going to use all of what we call the aggregate fields. Right? These are the sum for all the games. But because we have 2 different types of rows, it's very important to differentiate. Is it an aggregate row? So is it the sum of all the games for a given country? Or is it a game-specific row? When you click on the name of a country, you're going to expand and contract your table to show each one of the games that went into this sum. So we can see either a summary or specific. So that's why we have this type field. We're going to be using it a lot to be able to tell, is this one kind of row or is this another kind of row? In the data.json file, we've already told you that these are aggregates, okay? And then inside the games field, you see that this little bracket here, we have an array of games. So this is just an example, so we have 1, but how many of these would we have in this one? 7, exactly, because these are a result of summing 7 games. So you can look at your JSON file and really understand the structure. There are going to be 7 of these. And if you went through and added all the goals made in each one, you're going to get that number, and that number, and that number. Okay? So you pretty much have everything you need for your table in this JSON file. Notice that this has the same format as this. This is key value, that's key value. But the games are nested inside the aggregate for the country. Everything make sense so far? Notice that this type is different than this type. This is aggregate, this is game. So that when we're populating our table, and if you notice there's a difference in the way that the 2 rows look, right? So if we go back up here to what it's supposed to look like, here we have a row for the aggregates, and here we have a row for the games. Game rows don't have these values because it would just be a 1 or a nothing. So we said we're not going to populate these. This would all just be 1s. Game rows only have these 3 columns, and game rows have a slightly different aesthetic. Now, notice that this is very similar to that, except that, oh, this is an unfortunate example because you can't see the bars. The bars are thin and the circles are empty. Now, in terms of coding, what do you think is a good way where you have the same marker, and you're going to use the same metrics to plot it, but they look a little different? Would you, huh?
Classes?
Yes. You would style them in your CSS. So if you open the CSS, you'll see that we have different classes. We have a game class, we have an aggregate class. So you can use those. You don't have to make 2 completely different enter, update calls because one of them, there's a fill of white and the other one has a fill of a color. Okay, because these are going to be used, these are going to be plotted with the same commands. All of these are on that same scale. So you can do all your circles at once, but you're going to class some as games and some as aggregates. Now, where is the information of whether it's going to be classed as aggregate or game come from? Where in the JSON? Type. Right? So this is what we were saying. One of the learning goals of this homework is to use your data to class and to set your styles. And I'm going to be a little bit more specific about that later. But you want to be able to, all the information you need, we're not going to be using if-else comments to it. We're going to use d dot, it can be type, d dot data, d dot this, d dot that. Okay?
I have a question on the JSON.
Yeah.
Why is the key for the sub node different from the aggregate key?
Because it's that's a very good question. Let me bring it back to the JSON. So the fact that this game was played by Brazil is inherent to the fact that it's a child of Brazil. Brazil played another country. So the information here is who the other team was. So it's Brazil versus Netherlands. Brazil versus whatever. Right? So the idea is this is an object where we want to name it something, and we have all of these attributes relative to that name. Now this only has meaning because it's nested inside of Brazil. This object somewhere else looks like it's just the Netherlands was one playing, but you don't know against whom. The only way you know that this was the Netherlands-Brazil game is because of the structure we gave you. And I'm going to talk a little bit about how you use that nesting to be able to create the row at the right place.
So is there another game node somewhere then where the key is Brazil and the opponent is Netherlands and everything is just...
Yeah, there should be, right? Like
yes.
When the key is Netherlands or the outside key, the previous array, if that is Netherlands,
that
then
same
it will
name
have,
will show up?
yeah, the same
As
name.
a child,
Okay.
yes.
Okay.
So there's a little bit of a double encoding, but it makes it easier for you not to have to go in and, so that's the kind of idea of giving you the JSON file as it is, so you don't have to do any of the data manipulation yourself. So yes, if you go into your Excel file and you find out where your Excel file, wow, your JSON file, there is a key Netherlands and Brazil is one of the games. And so that's what I was saying, in your CSV, if you're going to do the hacker version, you'll see that you have games presented twice. Okay? Okay, so that's our data. So the first thing you're going to do is you are going to draw a scale. You're going to make a scale, you're going to set your axis, and you're going to create a list. And you know what I'm going to do? I'm actually going to go ahead and Let's find. So here you'll see that we gave you all of these, right? So you're going to be storing your data. I'm going to talk about table elements, but team data is pretty much your JSON file. It's that huge structure. Okay? It's going to go to team data. We're going to talk about table elements in a bit, and then we give you this so you can create your cells exactly that size. These are the ones you're going to use when you want to grab all the goals made and all the goals conceded. And so you save that in a variable, so you can call this variable. That means that if you went into your, we were still using a CSV file at the time, and changed your header, you would just have to change it one place and not in your entire code. So whenever you want to call these two, you can use these. And now here we gave you a whole bunch of scales. A goal scale, a game scale, aggregate color scale, and a goal color scale. And we give you the ranges, you have to set the domains. So if we go back real quick to you'll see that these are just mini plots, just similar to what we've done before, right? We've had rectangles. So we have two different scales here. All of these are what we call the game scale. They're going to go from 0 to whatever the maximum number of games were. So when you're setting your domain and you have your data, you know that the minimum number is 0, and the maximum number is however many, the total amount of games that any given country played, okay? And see what I just said there? It's not the total amount of games played in the entire tournament, right? It's the total amount of games one given country. Because for a given row, you're never going to have more than what one country played. And these are the same scale, even though you're never going to have a full 7 here or here, so we can compare the size of these. So this is one scale. You get your data and you set your domain. We've already given you the range. This is another scale. And this is one of the parts where you have to think about what your scale is, because we're plotting 3 different things in here. We are plotting the number of goals a given team made, lost, and the difference between them. What is the smallest possible value this can take? This is absolute value, right? What is the smallest possible number of goals you can make or lose? 0, right? That's a good starting point. What is the maximum possible value there? We'll take 18. Yeah, what is the maximum? But where did that 18 come from? Where?
The aggregate.
What?
The total, the sum.
So you would think that it is the sum, except
Max of the aggregate goals, I guess.
Maximum of the aggregate conceding and the receiving goals.
so
Maximum.
yes, there's 2 things that we're plotting here, right? So it's the maximum aggregate of, there are 2 variables, goals made and goals conceded. So it's the maximum, exactly, of both of those. You want to make sure that you, for each data row, when you're creating that domain, that you say, what is the maximum number of goals conceded or made ever, right? My point is that you have 2 variables that are going into creating the domain, the number of goals made and conceded. Because you could have the case where you've only ever made, let's suppose, let's forget the Germany-Brazil disaster. Let's suppose you've only ever made 4 goals. That was the maximum anyone's ever made. But another country lost 13 goals. In this scale, where you only have positive values, your red dot's going to be way over here at 13. And you need to account for that. Or let's suppose you have games where no one ever, at most, only got 1 or 2 against them, but made 13. Okay? So you're setting your scales, that's the first bit. And then in the same step, you're also, since you set the scale, you're going to draw this axis here. Now, one of the things that's a little bit of a pain is positioning this axis. So what we've done is, if you look at the HTML file, we created a little TD, which is a cell element, and gave it an ID. So you can just select that and draw the axis in there. So the nightmare that was for a lot of people in homework 3, transitioning, translating y minus the height times the date of your mother's birth, none of that is going to come into play here. You're just going to select that element and put the axis there. What we really want you to think about is what data goes into selecting these scales. Okay, so we're pretty much done with part 2. Scales, axis, and list. Now the list is the big concept here. Every time, the idea interacting with this is that when you click on a certain country name, that rows magically appear with the games that that country played. And then when you click on it again, it collapses. What this means is that the data you're using to populate this table is changing. Okay? Now this is the part where Alex even added this after I wrote the documentation. I don't know if it's here, but that we picked an approach, which is this list approach that I'm going to explain to you guys. If you say, you know what, I don't think that's the best approach, I'm going to try a different one, that's perfectly fine. This is just the one we suggest. It's not even necessarily the best, it's one that is feasible and that is easier to implement, okay? So the idea here is we are going to keep track of a list of everything we want to put on this table, whether it's an aggregate or a game. We're going to keep, and whenever we make a change and we click on a country, we update that list, and then we update the table. So you're not going into the table and inserting rows, deleting rows, you're updating the list and feeding the list into the table, okay? That's the concept here. Now here's one of the parts where it's very important that our data has the same format, okay? Remember that if we're going to give it a list of objects and we're going to populate it, that means that all of those elements in the list have to have a key and a value. Otherwise, when you do a D3 select all, you give it a data, and one of them has value attributes and the other one doesn't, that would break. And that was part of the data aggregation phase. So when we think back to our JSON file, notice that the games have the same look and feel as the aggregates, they're just nested. So the key thing here is going to be taking these game objects and putting them in this master list, just like we take the aggregates and put them in the master list. Except one of them is inside the other. Once they go into the list, they're all the same and they all get rendered the same. Except there's one difference, which is the type field. And we're going to use that type field to give it a class and to style it differently, okay? So for this here, remember how we said we had team data? Team data was your raw data. You're going to read in the JSON file, give it to team data. I think we actually gave you that. Did we give you that? Yeah. That's what we do. We read in the data, we feed it into team data. Now we're going to create the table, and we're going to update the table. Okay, so first we're going to we created the table. Well, creating the table is actually putting the x-axis, setting all of your scales domains with your data, and then we put that. Now we're going to actually go ahead and update this table. Just think if I'm going to give the slides now. So I'm going to talk a little bit about how we pass data into that, and then I'm going to talk about the kind of data that we're going to put in there. So yes, this is probably a good time to come over my slides. So this is a slightly more involved example of what we did before, where you selected rectangles and gave it data, right? So now instead of rectangles, we're going to do this for table elements. Now a table is composed of rows, and within those rows we have cells. So if anyone has ever used HTML tables, you know that TR are the rows and TD are the cell elements, right? So the key thing here is to understand, where are we appending data? Are we appending data at the TR phase, or are we appending data at the TD phase, okay? Now, before we consider game-specific rows, let's just think of our aggregates. Our initial data set, as read in from JSON, if you forget the nested stuff, only has aggregate objects, right? And we want one row to represent one aggregate object. And when I say aggregate object, I mean an object that is the sum of all the games for a country, okay? This means that we want to append our data objects to the rows, okay? We're going to append that data object to the rows as shown here. We're going to run out of battery. Does anyone have a Mac charger on them? No? Oh, thank you. That's the old.
Oh,
Yeah, it's okay. We ran out of battery. So this is the syntax, the basic syntax of what you're doing, right? So you have a table, we already drew out the table in the HTML, and it has a class of tbody. Sorry, it's just that HTML type, so tbody, you don't need a hashtag or a dot. And you select all the rows, and you give it your data, so in this case, our data is what we read in from the JSON file, and for each data element, we append a tr, okay? So this is what that object looks like. So we're gonna have, and this was just an example, if my data has 4 elements, we are creating, no one saw this, you can't really cover up with the projector, we are gonna create 4 rows. However many objects you have is how many rows you're gonna create, right? So this is similar to the rectangle concept. Select all x and you give it data, however many elements of data is however many elements of x you create, okay? Except instead of these nice simple little numbers, if you gave the data 4 elements, we have 32 aggregate objects. So this is what we're associating to each row.
Excuse me.
Yeah.
Can you zoom in?
Yeah.
Thank you.
Better?
Yeah.
I have a question.
Yeah.
So like, where do you merge the selection with the original elements?
In the
So, like-
update. So right now, so this is just, you're creating your table for the first time, you gave it your data, right? This is first time you're creating the table.
Okay.
Once you update the list, and then you're gonna create new ones, then you're gonna have a dot data, and then you're dot enter, and then you're gonna say tr equals tr dot enter dot merge, tr enter dot merge of tr. So that's one extra step, but you have to do that after you do the enter selection. Okay. The merge thing is something that actually can get a little tricky. So just go back to one of the examples that Alex gave in the, I think I might have talked, no, he talked about that first. And use that same syntax where you can't, for example, you know how you can do chaining for a lot of stuff? You can't merge if you haven't defined your TR yet. You can't, I couldn't add merge at the end of this. I can't say dot merge TR because TR hasn't been defined. So you're gonna end that and in the next line you go to TR equals, okay? Okay, now this is the part that you guys have to understand. I'm gonna take this very slowly and you guys gotta ask me if you don't understand. So here you have your you have 1 TR per row. Now we're going to create cells, right? So we're going to do a similar thing. So we're going to do tr.select all TD. We're going to give data, enter, append. Now there's something here that's different that I don't think we've done before, which is instead of giving it data, our data operator has a function. Okay? So the key concept here is to understand that because we are doing a select all on this parent element of TR, the data gets passed down. So the data that we appended to TR is now getting passed on to the child TD. Okay? Does that make sense? This is going to happen as many times as you have TR elements. So think of this as happening 32 times for 32 rows. Okay? So that's one thing. Now, notice that I'm returning, this D here is the data passed in from TR, okay? Notice I'm not using it in this first example, but my function is returning an array of 1, 2, 3, 4, 5, 6 elements. So my question for you, given that that's going to happen 4 times, so 32 in our data, 4 in our sample here. So we have, right, 4 different rows. And this is going to get called for each one of those rows. Every time I call this, this is what my function is creating. How many cells are we creating for each row? 6. Okay? So that's what, once we run this, you're going to get 4 of these. Which data goes into each one of those? Yes. Right? So at this point, you're going to get as many TD elements as your function is returning. Right now, we're not using the D, but notice we have access to it. So in a slightly more elaborate situation, which we're going to go next, instead of returning X numbers, we can return numbers that are a function of the data passed in. What is the data that's passed in? The data from the TR. What did we give the TR as data? The aggregates. Those huge objects, right? Those huge objects that had all the information that we needed. big is this element right here? TD. How many elements are in there? So who thinks it's 6 elements? Who thinks it's 4 elements? Who thinks it's 6 times 4 elements? So that's the key thing to understand here, is how many times this is getting called and what is this generating, okay? So this had 4 elements, so this is gonna kind of run 4 times. And then for each one of these, it's selecting all the TDs, which right now don't exist yet, but the number that you would return here is how many it's gonna return, which is very similar to our initial tr.selectAll data. Our initial data set had, well, for in this example, 32 in our homework. So you have 32 TRs. For each one of those, you're selecting all the TDs and giving it X amount of data points, whether it be this or something as a function of D. If anyone didn't understand that, now would be a good time to, okay, great. Okay, now we're gonna go to that slightly more complicated version. So here, we didn't use the data that was being passed down. I use this as an example for you to understand how we're generating these cells, but we should, right? So this is the syntax of using the data, and this is exactly the syntax you guys are gonna use in the homework, a little bit more than this, but this is actually even the field names that we're gonna use. So here, we're gonna create, now here's my question. How many cells are we creating per row in this example? Pay close attention to what we're returning there.
3.
3.
Anyone else?
2.
So we have 2, we have 3. Anyone else? The answer is 1, and I want to know if anyone can see why it's 1. Yes.
Because the key value has.
Yes, they're key value pairs in an object. Just like with JSON, we had key and value. This is one object. See how there's a curly braces here? Inside this one object, we have a type field, a viz field, and a value field. But it's one data element, right? So right now, if we ran this, it would create 1 row. But the reason I'm showing you this is because this can have as much information as we want. This is the step where we're saying, okay, I had the aggregate, the big aggregate with everything, but now I want to specify what's going to go into this specific cell. And I want to keep track of 3 different things. I want to keep track of what I want to plot, which is my value. I want to keep track of what kind of viz I want to make. And I want to keep track of if it's an aggregate or game. I hard-coded these in. You're not going to hard-code those in, because all of that information, except for this one, is in your aggregate value, right? So what can you replace this with so it still says aggregate? Yes, but not just type. What is the D in that function? The D is the data object that has the aggregate information in it, right? So the D is one of the JSON objects. Remember, every row got 1, and every object has all those fields that we saw in that initial description. That's what that D is. Instead of aggregate, we can say D dot type. And that is going to automatically pass on the type from the row aggregate into this specific cell. Okay?
So do I have to specify the fields here again, or just pass the whole object?
So you don't want to pass the whole object. Here you can just D.type. You do have to specify these 3, type, viz, and value, because that's what we're going to use when we're generating the viz, right? This structure allows you to have the number you want to plot, the kinds you want to plot, and if it's an aggregate match. And we're going to use that later on. But after designing this, we said, if you have these 3 pieces of information, you can do the next phase. But what I want you to understand is how are we passing data on from that first JSON object down to the row level and now down to the cell level, okay? So remember, this is returning 1, so it's going to create 1 column. How many columns do we need in our final visualization? 7, right? Yeah, I think it's 4 or 5, exactly. Which means we're returning how many objects inside this function? How many do we want to return? 5, right? We're going to create 1 object per cell. As many objects as you return here is as many cells as we're going to create in that row. Which means that, and this I'm not going to show you because that's actually exactly how you implement this bit. But the concept here is you're going to return 4 or 5 of those. And each one of those is going to have a different data type. or a different, well, this is gonna be whatever it's always gonna be that type. But this is gonna be different, and that's gonna be different. So there's gonna be a little bit of an if-else here, right? Because if, and remember, the order that you return these in is the order that it gets populated. Yeah,
Does the syntax always require the curly brackets for each object, or is that just because you hard coded it?
no, it does require that, yes. Unless you were returning whole D, right? Because then it came with the original D. But here we're creating an object with our custom-made fields, because we know we're going to use those fields. Now, this is the part where you get to tell it, see this string here? We're going to use it later. It's going to be bars, or it's going to be, it's in the spec, goals, or it's going to be text, okay? Because we have 3 types of columns. We're going to either be displaying goals, or we're going to be displaying bar charts, or we're going to be displaying strings. And the way that we are going to later select the cells to populate each one is with that field right there. The key thing to understand here is that we are associating this data object that we're creating to a TD. So remember that our TD selection has how many elements in it? So we have 24, right? 24 total TDs. And now in this step, we're associating each one of these TDs to a data object that has fields that are going to be useful for us. So you have everything you need to make your plots inside the data for those TDs. Before it was rectangles, now there's cells inside rows. Okay? And this becomes crucial because of this right here. This is also in the spec. Remember before how when you wanted to select all your bars, you would do a d3.selectAllRect or d3.selectAll chart or whatever? We had to give those things classes. Notice that here we start having several things that dictate how we want to plot it. Is it an aggregate? Is it a match? Is it a bar? Is it a text? Right? So instead of creating a cell that has 1 million classes to it, we are now going to use the data to select it. So remember, the data that we appended to each cell had that viz field in it, right? So now what we do is we say, okay, give me all the TDs. So give me all of the cells, and filter and only return the ones where the viz equals goals. This selection right here is all you need to feed into .enter, .append rect, or .append circle, or whatever. So this is the idea of selecting your elements, no longer based on classes or types, because you don't want to select necessarily all of the circles if you have circles in other parts of your visualization. You want to select it based on the data. Okay? Make sense? So those 2 bits of code are very useful. This one you're going to change a little bit so it returns more. And this one you're going to use to filter out when you plot goals, when you plot rectangles, and when you append text. Okay? So this, what I just did was an explanation of what we meant by this line right here, right? Where you're making all your TDs, and then your function of creating your data array is what I said, you create these objects. And inside these objects, you define type, viz, and value.
So I have a question.
Yeah.
So like, is that array or JSON object?
This one,
Like, what you feed the data?
in here,
Yeah.
so you are creating an array of JSON objects.
So it should have like.
It should brackets, yes. Just like we did for the data points in our simple example, 13, 7, 20, whatever. Instead of those numbers, you have little JSON objects. And each one of those JSON objects has a type of viz and value. Now here's a question. How do you decide what goes into the value field? Is it d.value?
Depends on what TD is. Sorry, the countries of the TD or country. Denote key.
Right. Exactly. So remember, you're going to return an array that has as many objects as you want to put in the order that you want to put them in those cells, right? So for the first element in your array is going to be d dot key. Perfect. The second one.
D dot value.
D dot goals made and D dot goals
D
conceded.
dot value.
So goals made. Is there a d dot goals made?
D dot value dot goals.
Yes, and
Oh,
that's
value.
important. You're going to, just so you understand, where is this data? Just go back to your original structure, right? So you're going to extract d.value.goals made. Now, this is where this becomes actually quite important. Hmm?
The second column.
Yeah.
You're doing the goals.
Yeah, but the goal is part of the value field of your aggregate object. And I'll go back to that in a second. Look at this. This is the D that's getting passed into the TD, right? This is the data object from the aggregate. So we know that the first one's going to be key, but everything else is nested inside value. So everything else is going to be D dot value dot, and because these two are used so often, we created the goals header. But if you actually wrote out the string, that would be the same thing. Notice that result is an object and not a single value. And yeah. Did I print out? Yes. Result, it doesn't have a single value. It has two things. It has a label and it has a ranking. Okay? So the reason for that is because one of the things you have to do is to be able to click and sort every column. And in order to be able to sort, this means nothing, right? You can't really sort by third place winner unless you associate a number value to it. So when you're going to sort the result column, you're going to sort by result.ranking, value.ranking. Sorry if saying value.ranking is confusing in terms of value of that cell.ranking. And then you're going to use the third place to actually append the string. Now, when you get to the result, right, column, like this is column 3, that means that's the third element in that array in the TD function. That means that your value in that spot is going to be this whole thing. And then when you actually go to create it, you're only going to use value.label for the string. And then when you rank it, you use value.ranking. Okay? Now, what is the type associated to the third column or whatever column this is in your array? Sorry if that didn't make sense. String or text, I forgot what we call it. So the same way that we did a filter, td.filter type equals bars, td.filter type equals text. And then you know that all the data in those are in this form. So when you go to populate it, you can say dot text, value.label, value.ranking. And one way to keep this really clear as you go along, yeah, go ahead, but let me just finish the sentence, is you do a console.log on what you think you're passing in. So at this stage, when you guys do this, and you have the slightly more elaborate version, do a console.log on what you think you're returning. And see it show up as an array of 4 values, and if those are the values that you're going to use to create your visualizations later. Okay? Did you both ask the questions you had?
I had a question. So these is something that we hard code inside when we are
Yes.
appending each object
Yes.
to
Yes, at this stage right here. So this is going to be a little bit more elaborate than this because you are going to be creating 4 objects, and each one you are hard coding the type. Okay? Because this is where you tell it, I want this row to be this column to be this column to be that. Okay, so we did a filter, then you're gonna, so this is, yeah, so the same concept, right? You're gonna select by viz, you're gonna select goals and populate the goals, and you're gonna do the same thing for the round result, wins and losses. Now here's the part where you have your whole tables populated with aggregate rows, and now we want to be able to add games. So this is the idea of updating the list. So far our list was just the input of JSON, right? Now we want to be able to click, so we're going to do a callback, on callback for any of these. And we're going to say that when someone clicks on this, we want to update the list for this game. Now when you do an on-click update list, you'll see update list has one parameter, which is I. The table will know what row you're at. That I, when you do on-click function update list I, this is whatever, and so whatever row you clicked here is the equivalent row in that master list that you fed in. So you know exactly where to go in your master list to grab the games. Okay? So the concept of updating the list is the following. you're gonna go through your list, you have your index I, so that's the 7th element in your list. The data object at the 7th element in your list is the same data object that we've been dealing with all along, that aggregate. And that aggregate has a field called games. And that field games is nothing but an array of game objects that look just like your aggregate object, except they're nested, right? So what we do is we insert each one of those games into your list below the current element. So the idea is you get an array, our table elements is the name of the list that we're feeding into our visualization. And it's an array of objects. And we know that the 7th element of this one is Germany. So we're going to go to the 7th element. And we're going to go into the Germany element games. And for each one of those, we're going to do a table.splice, and we're going to add that in. Splice is the name of the array operator to insert a row. So you're pretty much just inserting objects into your, when I use list and array interchangeably here, okay? Because the order of elements in that list is the order it's going to get right into the table. And we want the games to show up right below the aggregate row. So you find the aggregate row, and you pretty much insert each one of its games into the list. And then you say update table with that data. And all the code that you wrote to make the aggregate table is going to work perfectly for your games. Because your games are objects that already know they're games. Their type is games, right? So when you're going to go and create your visualization for the aggregate rows, you selected all of the goals of type aggregate, and you drew them one way. Then you're going to go, now you selected games, you're going to draw them the same. They're going to be the same thing. They're going to be same thing. They're going to be circles. They're going to be games, right? The type is games, which means that you can use CSS to style them a little bit differently. What happens when you click on that same country again? What collapse? What does that mean in terms of our list? We're going to delete those rows, right? So you're going to go to that same element 7, and you're going to go and take out the rows. So you're going to splice them one by one off. Okay? Now there's another function that you're going to write. It's called collapse list. You're going to use that before you sort, and I'll tell you why. So the collapse list means I want everything to be collapsed. This is the easiest thing you can do. What are you going to do? You're going to go through your entire list and
Remove everything that's a game.
remove everything that's a game. How do you know it's a game?
Because the type.
Got type. Right? Now there's one thing that's, I actually hadn't thought about this. I found a solution online, so I thought it was genius, which is you have an array, right? And you want to delete an element. So you're going to go for I equals 1 through length of your array. And then you find one that you want to remove, and you delete that one. Your I doesn't mean anything anymore because the I was indexed with all of the elements. You cannot go through deleting. So does anyone think of what's a really smart way of dealing with this?
You just store the indexes and then you go through and remove them all at once.
That's definitely a way to do it. Or you start from the end. So it's really, instead of going I equals 1 through length of array, you say I equals length of array minus 1 to 1. And then you can chop them off and it doesn't change anything with your indexes. If you chop off 36, 35 is still there and it was always 35. So you just backwards take out all the ones that have a type game and that's it, you're done. It collapses the whole thing and update your table. Okay, so those are the 3 operations you want to do to your table. If you click, you want to add the game rows. If you click again, you want to take out the game rows. Now, here's another question. How do you know if it's already been clicked? What is the click and click again? How do you really know that?
Class.
Hmm?
Like if you add a class or something.
You can add a class. That's one way of doing it. Alex actually, after I implemented it another way for my solution, suggested also a flag as part of your data element, which I think is a little more elaborate, but it's the same thing. And what's another way you could do it that's kind of more
Maybe
brute force?
Maybe check the next correct row.
That's exactly how I implemented it. You can implement it anything you want. That's the first thing I thought of as well. Check the next one. So if someone clicks on Germany and the I is 7, you go to your array 7, check 8. Is 8 a game or an aggregate? It's a game? Well then delete. How many rows are you deleting?
Number of games.
The number of games. So you are going to delete as many elements as that aggregate has in the game field. Okay? There's one case where that breaks though that you have to account for, which is what? When can you not check where the next element, what the next element is? The last one. It will break saying there is no I plus 1. So you say if your I is the length of your table, then you know it hasn't been expanded. Or if I is less than the length of the table, check I plus 1. Which is why maybe a class or a field is another way. Doesn't matter. The point is, if it's been clicked, add them, remove them if it hasn't, add them, and collapse, go through and take all the ones that are game. And that's it. You're done with the first part. Okay, so the next part is sorting. So for the sorting, this is where you're going to call the collapse list that I just talked about. So the idea of sorting is you're going to set the on-click for all your headers so that it actually sorts by a certain attribute. Okay? And you can, for that, you give it a comparer, anyway, a function that compares A and B. And you have to take into account two scenarios, where they're number values and where they're string values. Because you want to sort the countries alphabetically and you want to sort everything else by value. Okay? When you hit sort, what is the behavior that you expect if your table is expanded like this?
Collapse first.
So that's the way we solved it to make it simpler. Because if you go to sort this and you don't collapse it, these get sorted and they get inserted in the middle, that doesn't mean anything anymore, right? So the way you have to implement it is just before you sort, collapse it, okay? But one of the extra credits is, instead of collapsing it, sort the aggregate ones and then sort these as well. But keep them in the same place as relation to the top one. It's a recursive sorting. So yeah, if you have some time, I think that's 5 or 10%.
Should we sort mates based on goals too?
Oh, yeah, that's a good question. The property you're sorting by there is the difference of goals, so it's a delta goals.
Positive.
Say that again?
Positive and then 0 and then negative.
Yes. Oh, and that's one thing, it's in the text that I didn't explain. The red bars are when they lost more goals than they made. So they lost, on average they lost, and on average they won. And Switzerland is neutral. So yeah, you want to color those in gray. And the aesthetics of that is, okay, so now let's go to the tree. The tree is really not as hard as it looks. So we've made our table, we've learned how to update it, how to pass data from TR down to TD. Now we're going to create a tree. So this is pretty much all you need to know for the tree. You're going to use d3.tree. It's a different layout. Okay, we haven't covered this layout in class, but it's similar in the sense, you know how we did the force layout? So every layout has certain parameters. And so if you go into the documentation for d3.tree, you're going to see that you can set a lot of things like how far apart the nodes are. You don't really need to, but these are things that every layout has. But the concept of this is you feed it in nodes and edges, and it will tell you the position to put these nodes. Just like the force layout gives you the position to put. That's what the layout does. Layout will return where you can put your nodes. So in order for, we give you a CSV file. The FIFA matches FIFA-tree.csv. And we read it in for you too, I believe. No, you don't. Oh, here it is. So we read in the data, and we give it your CSV data, and you have to implement create a tree. Now notice that we created a new field for each element, which is an ID, because in order for the D3 tree layout to work, every data object has to have a unique ID. And right now we don't have unique IDs because countries show up in more than one game. And so we create a unique ID by creating a string that's team, opponent, and its position in the row. It could be anything. You could use a random number generator there and it will work. We just want to make sure every element has a unique ID. Then, before you can actually feed that into d3.tree, you need to stratify it so that pretty much will create the structure of parents and children. And so this is the syntax. It's very, very simple. It's going to give you the root. This root object has in it all the children. So this is going to do all the work for you in terms of putting the root here and the first two children here and so forth. Now here, the ID, what is the ID in our specific case, in this data set? What are we returning there?
Key.
Anyone else? This has nothing to do with the game data set, right? I mean, it's still games, but this is FIFA-tree.csv. This is the one we just read in, and what did we just create? Yes. Where did we store that? What was the name of the field that I just showed you? It was like one of those memory tests, right? ID. Very hard, right? Which means that you guys are going to do this, but instead of name, it's going to be, this is from the documentation. So you said ID. You're pretty much telling it what is the field that it should use as an ID, because it needs one. we happen to call it ID as well. If we knew that there was only ever one row for every team only had one, we could say D.team, D.name, D.whatever. It had to be unique, and none of those were unique. And then the parent ID, you're going to give it the field that contains the parent. And that would be? Actually, I'm going to let you guys think about it. So you pretty much said for each one of these data objects, I have a unique ID and it has a parent. Now for you to really know what to give it there, you want to open up FIFA-tree.csv and look at all your columns. One of them has to do with, exactly, right? And then you're going to go through with that, the output of d3.trees, and you're going to create this beautiful layout. Okay? Now, there are a lot of examples. Okay? You guys don't have to, you can look online and see how trees are made. Okay? Because you're going to be creating these nodes, and you're going to create these edges separately. So you're going to select all circles and make them nodes. You're going to select all, what we call them links. You can call them anything you want. In terms of the styling, what I suggest you do to find out what we call these dot links. All of these are links. That's why they're this beautiful semi-transparent gray. Go into the CSS, the style.css, and see what classes we have defined there, and use those. Because if you don't, you're going to get this ugly black thin line, or you could, but then you have to style it yourself. So it's also a hint as to how we group things. There's a dot link, there's a dot node. Okay? We have a dot winner and a dot loser, and those happen to have these colors. So just assign those classes to your nodes. So the styling is kind of done for you. You just got to pick the right ones. Okay? And then the last step is linking the two. Okay? Now remember, they both have the same information, they just came from different files, right? So what we want you to do is when you hover over any of those rows, that you highlight the appropriate, you highlight all of the nodes or paths that have that country in it. Okay? Now remember, what was the data that we associated to each row? A JSON object, right? And that has the team in it. The key is the team, right? So when you create that TR, you're going to do it on hover. Now you have a behavior that you want to associate when you hover over the TR. On hover function D. That D is the data associated to that row, which is that JSON object that has the country name, right? So now you have access to the country that you want to highlight here. So you can go and select all of the elements that have that country in its data and set the class to selected. And you'll see in the CSS that that selected means it's red. So you have the data and it's associated to all of your elements. So what you're doing is you're using that data to filter and select other data points that have that same data value and classing and unclassing them or creating objects. Okay? I feel like that last bit's the one that got the least bit of nods. You guys have been looking at D3 stuff for way too long today. And that's it, and you're done. Have you guys clicked on the demo? The super cool demo? You're gonna see how many times I remade this. I would make this and Alex would go, let's go with blue. So I'd make it again, post it. He goes, you know what, green was better. That's green. He goes, you know, your table's too skinny. So that's where you can sort, click on them, and it sorts. If you click on it once, it sorts one way, you click on the other, it sorts the other way. So this is one that inside your sorting function you check. Is it sorted one way or the other? And if one way, then okay. And that was it. Are there? Okay, there's two things we can do. Does anyone here want to hear about the hacker version, or do you think that this is probably enough?
One question before that. What's the policy on extra credits? Is it for independently for each homework or?
Yes. What do you mean? I said yes and then I asked what do you mean.
Is it extra credit as the whole score that we get for the course?
Yeah, so for example, this one, oh, I see what you're saying. No, it's another 10 points, so if it's 10%. So for example, 10% into the hacker version, I think 5% for the sorting games. That means that if you do that correctly, we'll add 10 points. 10% of the total value, not 10% of what you got on the rest. I don't know if that was the question. So just think of it as points.
No, I mean, if I solve the homework completely, do I still need that extra credit? Does that help me anywhere else, or?
It will help you in the later
Yes,
actually.
does that carry over to the entire tally? I guess
As
that's
in,
what.
Yes.
say for example on homework 2 you got a 90 and you get a 110 on this one, does that?
Yeah.
It will carry till the end.
Totally.
I think the question
Jesus,
was,
this is very complicated.
the question was, does your extra credits
Carry
for
over to your
each
other
homework accumulates?
It accumulates in the sense that we add up all the points.
Okay, yeah, so yes.
Yes.
Yeah. So for example, if I get 90 on homework 1 and 110 on
Oh,
homework 2.
I think the answer to your question is the following, and I don't really know. Does Alex weight all the homeworks equally? That's the question. Because if he does, then yeah, they're all points, right? You're just adding points. If all the homeworks were worth the same, and they're all worth 100, but is he going to weigh the 100 that you got on homework 1 the same as you get on homework 6? And actually, Yogesh and I were talking about that in terms of, and that's his decision. If he does weigh them all the same, then yes, it doesn't matter where you get the extra credit. It's all the same. It all sums to one big lump sum that's divided by the number of homeworks. If he weighs them differently, then 10 points of extra credit on a hard homework is worth more than 10% of the first one. I don't think he weighs them differently. I think it's all the same. But don't take my word for it. You're looking at
And
it.
if I get 110,
Yeah.
is it better than 100 or not?
Yes.
That-
Yes. Oh, you're saying, does it matter if it's only for the sake of getting to 100? No, 110 will, yes, it does. I now understand the question, sorry. Yes, it influences all your total score. It's not like it's only to get to 100, yes.
So I have a question about the column goals.
Okay.
Because as far as I noticed, you have two elements to, those bars
Yeah.
and circles.
Yeah.
So what is the feeling between the circles? It's a rectangle or path?
That's a very good question. I implemented it as a path. And then Alex said, you know what, let's go. Actually, I started with a rectangle, and he goes, no, make it a line. I made it a line. He goes, you know what, rectangles are better. So, in other words, you're not going to get discounted. You can do it a line, a rectangle. Rectangles are easier, honestly, than having to do. Because the path, you're going to do a path generator, where x and y are two values. And with the rectangle, you can just you translate it by the number of goals, the smallest of the two circles, and the width is the biggest of the two circles. It's really however you prefer. It doesn't matter. You can do a line or you can do a. Which reminds me, actually, I was going to say this and I forgot. When you remember how when we were assembling the data values for the TD, you need quite a bit of data to make those goal charts, right? So you can't. Our value field is not going to be one number. Our value field is going to be how many numbers? How are you going to generate this figure with one number? Oh, it's 3 numbers. Wait, why am I number 2 here? You can create this with one number. Value is going to be d.value.total games, d.value.losses, right? d.value.result. This has two fields, but we already gave it to you. We gave you one object with two fields that are going to be used here, right? How many do we need here?
3.
3 or?
2.
2. You can use 3 or you can use 2 because we calculate delta goals or you can calculate delta goals, okay? Which means that you are assembling this value. The value field of the object in your second TD is going to be an array of 2 or 3 values. Or 4? Why are we giving 4?
You can say whether it's blue or red and then.
You could calculate it there, you could, or you could use, or you could calculate it when you're drawing it. And that's actually, it brings up a good point. At what point do you make these decisions, right? For example, do you say right there color red as a field? Or when you're giving the color, is the function that you give as the color attribute a function of your data? If value 2 minus value 1 is less than 0, fill red. Or class loser, whatever you want to do it. Or, so there are different ways that you can pass that data along. When it comes to styling, I highly recommend you don't embed that in your data, that you make that decision when you're coloring. Okay? I don't know if that was a joke, but that was actually the point. Yeah. So yeah, just think about what you have to feed into each TD to when you go and select them, know so you have enough data to draw these. Okay? I was going to say something else. Okay. Are there any more questions? Now is a good time. Does it seem any less daunting? No.
Yes.
Does it seem more daunting? Is this how Alex feels when he asks people to raise their hand and no one raised their hand? Okay, has anyone, yeah.
Sorry, can you please tell us again what was the ranking?
Yes, so the ranking is the result field, looks like that. Looks like this, right?
Yeah, where would we need that?
For sorting the results then,
Or sorting with respect to,
with respect
Excel.
to results, yeah.
When you click on that, one of the features you're implementing is when you click on column header, it sorts, right? So how do you sort something that's a string, and if you don't want to do it alphabetically? You need to have a value associated with that string. That is what this is.
oh,
This right here at the top, you won't need it because we've already included that in the JSON file. This was when we were making it part of the, where you had to associate it. If you're doing the hacker version, then this is what you use. We said, okay, we're gonna give a number value to each one of these categories,
yeah.
and then we're gonna, so you use the number to rank, to sort, and you use these as strings. Okay. Is anyone staying for office hours, or have people not started yet? And it's okay if you haven't, I don't mind. Okay, great. Next Thursday, yeah.